So we'll move on with the next issue, that is threading issues. The next point from the threading issues, that is signal handling. So before that, what do you mean by a signal? So any event that has occurred, that should be notified to the process. So that notifying is done by signals. Okay, so signals are used to notify a process that a particular event has occurred. Just take an example like you're trying to divide by 0. Then in such cases, if you're writing a program, what you will write, you will write if that condition is, if you're coming across such kind of situation, then you might write some code like illegal operation, like that. Okay, so that's just an example. If you're trying to divide by 0, then in such cases a signal, that signal can be generated. That signal has to tell the process that some illegal operation is been happening. Okay, so signals can be either asynchronous or synchronous. So whether synchronous or asynchronous, both follow the same pattern. What is that pattern? So signal is generated by the occurrence of an event. So we can say an event has occurred which will raise a signal. That signal should be delivered to a process. That is the next step. And the third step, once it is delivered to a process, the signal must be handled. So the same example you can say divide by 0. That time what happens? An event has occurred and signal is generated which has to be delivered to a process telling that division by 0 is been happening. So once that signal is generated, once that signal is sent to the process, it has to be handled. Okay. Okay, then we can come to the next point, that is signal can be handled by one of the two possible handlers, that is default signal handler and user defined signal handler. So this default signal handlers are run by the kernel, whereas user defined signal handlers, that is written by the user. Just take an example like divide by 0. If such kind of event is been occurring, then we are going to print a message as illegal operation. So whatever default signal handler is going to do, that can be overridden by user defined signal handler. Okay, handling signals in single threaded process is easier compared to a multi-threaded program. Or single threaded program, handling signals is easier. Why? Because you have only one thread and directly you can send the signal to that particular thread of a particular process. But whereas in case of multi-threaded program, it is a bit complicated, where a process will have several threads. Then whom to send the signal, or to which thread we have to send the signal. So the following options exist, that is deliver the signal to the thread to which the signal applies. So in the first case, first option, what they're saying, you are sending the signal to a particular thread to which the signal applies. Second case, deliver the signal to every thread in the process. So we have a process which consists of n number of threads, so all the threads are sending the signal. And in the third case, deliver the signal to certain threads in the process. So in the second case, you said you are sending the signal to all the threads, whereas in third only some specific number of threads. Okay, and in the third case, assign specific thread to receive all the signals for a process. Like in class, how you have class rep, who is the main person, any information that is coming from the department, it will go to the class rep, and from him it will be forwarded to all the students. Similarly here also you can assign specific thread who is in charge of receiving all the signals for a process, and later on decision can be taken as to which thread the information has to be sent. So that is about signal handling. Okay, next we'll move on with thread pool. So there might be some situation like server is receives a request. That time server is going to create a separate thread to service that request. Okay, so there is a drawback in this. So time is required. So whenever a request is coming in, server has to create a thread for that particular to service that request. For each request, thread is created. So thread could result in, so it is possible that you might have unlimited threads which could exhaust system resource such as CPU time, memory. So we know CPU time, memory, all those are limited resource. So if you go on creating threads for every request that is coming in, there might be a point wherein we might come across situation wherein we don't have any more CPU time and memory. So to solve all this situation, we have what is called as thread pool. So what is this thread pool? So the meaning of this thread pool is we are creating number of threads at the process startup, or in the beginning we are going to create number of threads and we are going to place it in a pool where they sit and wait for some work to be done. Or okay, when a server receives a request, it directly takes the thread from this pool if one is available and tells the thread what it has to do. Once the thread completes its task, it will return back to the pool and waits for any other task. If there are no threads available in the pool, then the server has to wait until it gets a thread. Okay, so thread pool offers some benefits. What are those benefits? Servicing a request with an existing thread is usually faster than waiting to create a thread. So in the beginning what we said, every time a server request has come in, server has to create a thread. So in this case that is not there. Already you have some n number of threads which are present, so the time required for you to create the thread has been reduced. Thread pool limits the number of thread that exist at any one point. So again here, number of threads, there is some restriction, so there is no possibility that you might exhaust some system resource. The number of threads in pool can be based on the factors such as number of CPUs, amount of physical memory, and expected number of concurrent client requests. So how many number of threads you have to put in the pool, that is depending on how many number of CPUs are there in the system, or how many number of clients can be requesting at a time, and physical memory. So that is about thread pool. In simple words, if you're saying, thread pool is nothing but in the beginning when the process start up, we are going to create some n number of threads and we are storing it in the pool. So whenever a request is coming in to the server, so server is not wasting his time to create a thread. Instead what he is going to do, he is directly going to take a thread from the pool, so thereby the time required to create a thread is saved. Okay, in case if there is no thread in the pool, only in that case server has to wait until a thread is available. So that is about thread pool. Next one is thread specific data. So threads belonging to a process share the data of the process. This sharing of data provides one of the benefits of multi-threaded programming. So when we told about multi-threading program, we also told about the benefits of multi-threaded program, and that one of the benefit was sharing of data. So threads are going to share the data of the process. However, we might come across some situation wherein a thread might need to have a copy of its own, or another way, its own information or data. Okay, so such kind of data you're calling it as thread specific data. Okay, so what do you mean by thread specific data? There might be some threads who want to have information of their own, so they are called, or such data are called as thread specific data. Example, in a transaction processing system, each transaction is serviced in a separate thread. Each transaction may be assigned a unique identifier. Now same thing, you're withdrawing amount from the ATM, so right at 9 a.m. if you're withdrawn, that is one transaction. Again 9:30 if you're withdrawing, that is another transaction. So each of the transaction are given a unique identifier, that is the thread specific data. To associate each thread with its unique identifier, that is your thread specific data, you can say. I hope you have understood this. Thank you.